AI has already featured a few times in the presentations today, and we are at an inflection point, if you like, where we have to determine whether AI is the apotheosis of human ingenuity, or is it apocalypse around the corner? There are times when you think the ominous is very impinging, and there are other times when you think AI is going to open up a golden future for us. I'm sure that at the ACJ, for instance, we have taken AI very seriously, more seriously than just the buzzword that it's meant to be over the last few, particularly the last couple of years. And as I indicated, we are planning a serious attempt at creating a media hub for AI at the college in the coming academic year. And therefore, we were very keen that we should have someone associated with AI, and we were very lucky indeed to be able to get our chief guest today, Dr. Manish Gupta, who is a senior director of Google DeepMind, leading teams conducting AI research across India, Japan, Singapore. Previously, Manish has led VideoKen, a video technology startup, and the research centers for Xerox and IBM in India. As senior manager at the IBM, T.J. Watson Research Center at Yorktown Heights, New York, Manish led the team developing system software for the Blue Gene L supercomputer. IBM was awarded a National Medal of Technology and Innovation for Blue Gene by the then US President Barack Obama. That was in 2009. Manish holds a PhD, of course, in computer science from the University of Illinois in Urbana-Champaign. He has co-authored about 75 papers with over 8,000 citations in Google Scholar and has been granted 19 US patents. While at IBM, Manish received 2 Outstanding Technical Achievement Awards, an Outstanding Innovation Award, and the Lou Gerstner Team Award for Client Excellence. Manish is a fellow of ACM and the Indian National Academy of Engineering and recipient of a Distinguished Alumnus Award from IIT Delhi. Dr. Manish Gupta.
Thank you so much. It is really my privilege to be here, and it was so inspiring to see those examples of the amazing work that all of you journalists do day in and day out. So really appreciate this opportunity. So before I kind of talk about the work, let me also say it's always wonderful to be visiting Chennai. I have a connection with Chennai, not like having whatever, being born or anything, but I was born in Delhi. But in New Delhi, there was a school called Sardar Patel Vidyalaya that I went to, founded by Gujarat Education Society. And they made us learn a third Indian language. And I was assigned Tamil. So I still remember a little bit of that Tamil. So I'm going to maybe fuse some of that Tamil and maybe AI and see if, I haven't tried this yet. This is the first time I'll try. Because I tried it with a production version of Gemini. I've just signed up to a team food version, which is reflecting the work that my team does. For a demo I want to show later, but I want to see if it recognizes at least my Tamil. So let me ask Gemini.
Hello.
Tamilukkum amutendre per, andak Tamil, inbat Tamil, yangal urukkaner. Who wrote this?
I'm sorry. I'm having trouble retrieving the answer.
Okay. So I'll have to talk to my team about this. So the production version was working better. Anyways, let me come back to this version to show Haryanavi version, which I hope it'll do better on. So today I'll talk about a topic that no longer is only being discussed by us technologists. Today, the entire world, in fact, we see prime ministers, presidents of countries thinking about AI. And in fact, recently there was an AI Impact Summit that India hosted, where so many heads of state attended because of again, the amazing impact that AI is having on every industry, every aspect of the world. So what I'll do is share a quick kind of a tour, historical tour of how we got here, and at least some view of where we are headed. So I come from Google DeepMind, where our mission is to build AI responsibly to benefit humanity. And a very key aspect of that, which doesn't get as much attention, while we talk a lot about, there's a lot of discourse in India about AI being used to transform different industries, one aspect that doesn't get covered as much, but I did see it prominently mentioned in the remarks that Mr. Ram made earlier, is science, advancing science. So in fact, he referred to this Nobel Prize in Chemistry in 2024, which probably for the first time in its history didn't go to chemistry researchers. It went to AI researchers for the work on AlphaFold, which was an AI model which was used to understand, again, and predict the shape of proteins. So just to kind of go back to what really this whole problem is all about. So if you go back to your high school biology, I'm sure you'll remember at least the fact that proteins are the basic building blocks of life. Everything that we do is made possible because of proteins. Now, and they're comprised of a chain of amino acids, which folds into a distinct shape. So it's always a unique shape that that chain of amino acids will fold into, and that's what gives a protein its distinctive properties. Now, what shape would that chain of amino acids take? That's called the protein folding problem. And if we go back, let's say, around the time that this awesome class, right, the best ever class of ACJ graduated, 2001, we were working on a machine called BlueGene at IBM. And one of the motivating applications for that machine, in fact, the reason it got the name BlueGene was protein folding, to understand the mechanism of protein folding. In those days, it used to take an entire PhD, about 3 to 5 years of research, to uncover the structure of a single protein. And then there used to be this contest held every 2 years called CASP, where for newly discovered protein structures, right, where the structure had been discovered through experiments, X-ray, crystallography, and so on, those were given as test examples. And various models, software models, would compete to see which model got the closest to predicting the shape of those proteins. So the contest in 2018, which was CASP 13, the 13th edition, was won by an AI model called AlphaFold. And the next competition, which was held 2 years later, AlphaFold not only won the contest, the predictions of AlphaFold, which are shown here in blue color, they were so close to the actual shape of those test proteins, target proteins, which is shown in green, that the community considered the problem as solved. So not only did AlphaFold 2, it was AlphaFold, the second version, win this contest, it pretty much solved the problem, and the community stopped holding this CASP competition because they said the problem is effectively solved. And in fact, in subsequent years, in fact, the following year, the team behind AlphaFold, it made predictions of all 200 million proteins known to humankind freely available, which was equivalent to like 1 billion PhD years of work that was done in a single year, and made it freely available to researchers And this slide is outdated. There are today over 3 million scientists, including about 1.8 lakh researchers right here in India, who are working using AlphaFold for a variety of problems, ranging, of course, from drug discovery. Drug discovery is a very important problem because, again, depending there the structure, knowing the structure is important because you want to design the drug molecule such that it attacks that particular protein, right, that it is meant to guard against. Now, not just that, but even applications like designing an enzyme to make plastics degradable. You have people working on this. So our founder, Demis Hassabis, he refers to this as an example of these root node problems. Root node problems are those which are extremely hard problems, but once you solve them, you unlock solutions to so many other very, very impactful problems. So another root node problem that our colleagues are working on is clean energy. And in fact, today, all of the energy that we enjoy on the planet is ultimately derived from fusion, but fusion which is happening on sun, right? So it could be solar energy, or it could be solar energy that has been used by plants in various forms, and ultimately even hydrocarbons and so on, right? It's ultimately all derived from sun. Now, if you were to recreate fusion in a lab setting, it actually promises to give you an abundant form of clean energy. Because unlike nuclear fission, which is also kind of doesn't have emissions, but nuclear fission leads to radioactive waste. Whereas nuclear fusion doesn't lead to any radioactive waste, right? You have hydrogen atoms which fuse into helium, which is an inert gas. The problem is that today it takes more energy to get a fusion reaction going than what you get out of it in that lab setting. So there are various companies, organizations designing those fusion reactors with plasmas, and this is like an illustration of one such reactor, and the control of plasma in those reactors is now being controlled using these AI algorithms, these reinforcement learning-based algorithms. And my colleagues are very confident that we will soon reach that break-even point at which you produce more energy out of this fusion reaction than what you consumed to get that going. And once you reach that point, then hopefully we can work towards getting much more energy out and then making this actually practical for commercial energy generation. So these are examples of, again, hard problems that we have been tackling using AI. Another problem, which now doesn't appear so hard, but which has been fascinating, is weather forecasting, right? So those of you who might be like of my age, they may remember how inaccurate weather forecasts used to be. In fact, I remember there was a cartoon from R.K. Lakshman pointing to this person carrying an umbrella when the day, it's a bright sunny day, and somebody asks, hey, who's that? That's the weatherman who couldn't predict this is going to be a bright sunny day. And I remember that cyclone, that really, really vicious cyclone that hit the state of Orissa, where thousands of lives were lost. And the forecast before the cyclone, the same usual. कहीं कहीं बादल छाए होंगे, गरज के साथ छींटे पड़ेंगे, and generic forecast. Whereas today, these models have become much more accurate. But there again, my colleagues have been working on using AI to make these models even more accurate and faster. So in fact, they have been working on this problem of medium-range weather forecasting, and they recently did a comparison with the gold standard, one from the European Center for Medium-Range Weather Forecasting, and they showed that this AI-based model, GenCast, now called WeatherNext, it outperformed. And in fact, they started then deploying this model to do predictions at the entire planetary scale, and in particular, start predicting extreme events like tropical cyclones or hurricanes. And there was a hurricane that hit Jamaica last year in October. It was, in fact, when it was still forming, this team had been using this model to do the forecasting and working with the National Hurricane Center in the US. And about 2 days before that hurricane hit, it made a prediction that this is going to be a Category 5 hurricane. And this was kind of unprecedented to be able to predict it 2 days in advance, because normally it's only when you get closer to the hurricane being developed that you are able to do an accurate prediction. And sure enough, it did develop into that Category 5 hurricane, but thanks to the timely warning that came from this forecast, the authorities were able to do, again, take a lot of timely action, right? Unlike that case of that cyclone in Orissa, they were able to take a lot of precautions, like take that action. And this turned out to be the most, devastating hurricane in the entire recorded history of Jamaica. And there was vast devastation caused, and sadly there were a few lives that were lost, but many more likely would have been lost, but for the prediction that was made by this. So I wanted to share some observations that what some of these examples, what I'm trying to convey through these examples is that AI really has that potential to help us solve those root node problems where their solution will unlock many other advances. And as we think about implications for India, and this is again, I recently gave a talk to some of the policymakers, and I thought I'll repeat some of at least the recommendations that I was making, that Indian industry really lags behind global competitors due to our low investment in R&D. Especially if we compare with some of the leaders, like the US, which spends close to 3.5% of its GDP on R&D, China, which also spends something like 2.6%, India spends less than 1% of its GDP on research. So there's a need for us to change, for us to increase those investments, because they are likely to then pay off in the and ultimately deliver economic value, the way we have seen countries like US and China gain tremendous economic value, right, from their investments in research. So now let me switch to kind of more mainstream kind of areas in which AI is being applied. And before that, start with a very quick recent historical perspective of AI. In fact, the field of AI is almost as old as computing itself. But then there were many different approaches in AI, of which most of them fell by the wayside, but one of them, called machine learning, really started to show real traction. And machine learning is that branch where you have these machines which learn automatically from the data. You don't program them with rules like you do the regular programming of computers. In machine learning, instead of telling the system how to solve a problem, you feed it data. You feed it examples of how those problems are solved, and then let the machine automatically learn. And within machine learning, there were many different approaches. But one that really took off was something called deep learning. And I'm sure all of you would have definitely heard the term deep learning, right? So you're all journalists. How many have heard the term deep learning? I'm expecting a lot of hands to. How many of you understand the mathematical foundations of how deep learning works? Well, I'm not expecting you go behind the, I mean, it's not a technology audience, but what I can do is give you a very quick kind of a flavor of, because there is that perception sometimes beyond the technology community that deep learning is something like black magic, that nobody knows why it works, but it works. It is actually based on very sound mathematical foundations. It is loosely inspired by how the human brain works, loosely, not exactly. So in the human brain, if you go back to, again, our biology, high school biology, we may remember that human brain has these neurons, and which are interconnected. The equivalent of neurons in deep learning, in these neural networks, artificial neural networks, are shown in dot here. These are very simple mathematical units, which do very simple computations. Something like take the input, multiply it by a weight, add an offset term, and pass on the output to the next layer. Or look at all the inputs, take the maximum value, and pass that on to the next layer. Now, it turns out that if you take those very simple mathematical units, those neurons, arrange them together in a given layer, and you stack up these layers, and now you do computations. By computations, I mean, let's say, you fitted the image of a cat. By computation, I mean you're acting on the pixel values, right, of that image. And you do those computations. Towards the end, you do some, take the maximum value and come up with a number. And you could encode those numbers, right? You could encode the numbers to say number 0 means a cat, number 1 means a dog, number 2 means tiger, and so on, right? You could do that encoding. And it turns out that if you train this network, and training the network means coming up with those parameters, all those weights, right, that you're going to be multiplying those pixel values with, and so on, that if you train the network by feeding it lots of examples of images where you already know the answer, images of cats and dogs and so on, there's an algorithm that Jeff Hinton, who got awarded the Turing Award for his pioneering work, it was basically, essentially an algorithm where you're coming up with the values of those parameters such that the difference between what this network is predicting and the actual answer is minimized. And to minimize, so you set this up as something called an error function, and then to minimize that error function, to minimize the error, you have to choose those parameter values such that that error function is minimized. And if you remember even a little bit of that calculus, right, from your high school days, you remember, you would know that when you're trying to come up with the optimal value of a given function, you use differentiation. So basically, using the ideas of differentiation and so on, Jeff Hinton and his students, they came up with a very fast algorithm to train that network through this backpropagation algorithm, where basically it will come up with those values of weights, where it is now training that network to be able to solve this problem. And in fact, while all of that pioneering work was done in the 80s, for the next kind of 2 decades, nobody really paid much attention, because in those days, these neural networks were only working on toy problems. In fact, the AI community had given up on these neural networks, that they don't work. And in the year 2011, or was it 12, this deep learning technique made a comeback, where same researcher, Jeff Hinton, and his students, they trained that network, which now had a lot more computational power behind it, to really solve this problem of image classification. Given all these images, can you identify what's in that image? Once again, there used to be this contest held every year, and the neural network-based solution won the contest. And not only did it win the contest, it reduced the error rate by such a huge margin. It reduced it from something like close to 25% error rate to close to about 15 to 16% error rate. Now those error rates are very, very low. They do much better than humans. But soon after that breakthrough, on a broad range of other applications like speech recognition, given an audio, can you identify the words that are being spoken? Or given a piece of text, can you translate that into another language? So there were various machine learning algorithms that had been developed for all of these problems by researchers, and all of them fell by the wayside. This neural network-based architecture started becoming the best way of solving a very, very broad range of these problems. So you could consider the problem as kind of solved, but there were two main issues with this. One was that to solve any of these problems, you needed to label lots of data. So this image classification, this was enabled by millions of images which had been annotated by humans by hand. And likewise, speech recognition, again, thousands and hundreds of thousands of hours of speech was actually painstakingly transcribed, and those were used to train those models. So that was one problem. You had to do a lot of training, labeling of data. And B, for every new problem, you had to train a new network from scratch. And the combination of this meant that now for every problem, you had to invest a lot of effort to solve that problem using neural networks. And this is not how we humans learn. Given a new problem, we don't start solving it from first principles all the time. We build upon our years of knowledge, years of learning, and experience with similar problems to give us a starting point for solving a new problem. So that is what got enabled with this new paradigm called foundation models. And that's the paradigm that we are now in. This was enabled by a research breakthrough called the transformer architecture. It was famously presented in this paper called Attention is All You Need, written by these researchers at Google Research. Again, I'm reminded of kind of stories of like my own colleague at Google Research Mountain View who recalls his conversation with Ashish Vaswani in the micro kitchen of Google, where Ashish explained what he was trying to do. And this colleague of mine was wondering, why are you bothering? Doesn't sound like a particularly worthwhile direction. But this breakthrough, this paper, I believe has now the highest number of citations of any scientific paper in history. Several 100,000, or maybe it might have crossed even millions. I'll go and check. So this architecture got used in one of the models called BERT that Google announced the next year, which also used this principle of self-supervised learning, where you don't need to label all the data. So what BERT did was, it took all this text from sources like Wikipedia or digital books, a text like what is shown in the lowest most box. Obama was born in 1961. And then what it did was, it masked out 15% of the words. Now, and then started training a model, BERT, to predict those missing words. What does this remind you of? To me, it reminds me of this fill-in-the-blanks exercise that my English teacher, then even my Tamil teacher used to give us. Because through this exercise, the teacher was testing our ability to A, understand the language, and also reason about things from the context. So just like that, as BERT, and BERT, by the way, used that transformer architecture. So to predict the word born, it was looking at the surrounding text and what is known as the context window. So, and through the transformer architecture, it was able to automatically pay attention, more attention to words like Obama, 1961, Hawaii, that are instrumental in predicting the word born. There are a whole bunch of these matrix multiplication operations being done mathematically, but ultimately you are helping then through those contexts hone in on the prediction. And just like through that exercise, teacher was testing our ability to master the language and understand context. As Bird got good at predicting those missing words, it was not only predicting those missing words, it was solving a whole range of natural language processing problems quite well, including things like sentiment analysis. If somebody has written a story, are they saying good things or bad things about me or my brand? Or given a large piece of text, can you summarize it? Or can you answer a question? So BERT was one of the first, again, such models that took advantage of that transformer architecture and started showing those generalized capabilities. So fast forward to a few years later, Google researchers built this model called PaLM, which had now 540 billion parameters. And they did this very interesting experiment. They did the benchmarking on something called Big Bench, which has 58 different benchmarking tasks. So remember, in those days, for each problem, you had to train a new network. So for those 58 problems, there was a custom trained network, neural network, for each of those 58 tasks, right, which did best on that particular task. So this time, they compared the performance, the quality of this one model, PaLM, against those 58 best ways of solving those 58 different problems. And this chart shows the relative quality, and the bars in that orange color, they show that the custom trained model did better. But you can see that for a vast majority of tasks, the gray colored bars are showing that PaLM, that one model, did better than the best custom way of solving that specific problem. And this is what led Stanford researchers to coin the term foundation models. That today, when you are solving a problem, you don't need to train a separate kind of a model just for your problem. There's a foundation model which is giving you a very powerful starting point. And this is what has led now AI to become so mainstream, because now you have a few very, very powerful foundation models which are being used to solve a whole broad range of all kinds of problems in the world. So this is what these researchers showed. And in fact, the other interesting things that they saw was, not only was it solving now natural language processing problems, it could even do some mathematical reasoning, like solve puzzles like this. John takes care of 10 dogs. Each dog takes half an hour a day to walk. How many hours a week does he spend taking care of dogs? So they saw that this model could solve this problem, but only if it was given other problems that required similar mathematical reasoning, and it was also shown how to solve those problems step by step. So if it was only shown other similar problems, the model would still get it wrong. But now, if the model was shown a problem like this, Sean has 5 toys, for Christmas he got these 2 toys each, and you show the model how to solve that problem step by step. Reminds me of these instructions from my math teacher in school. I'm sure all of you had such a math teacher who would say, show me, don't just solve the problem, show me step by step how you have solved the problem. Now the same thing, if given, if shown to the AI model, you show them step by step how to solve the problem, and then give them a new problem and tell them, hey, think step by step and solve this problem. It was amazing, because here you can see that syntactically, this piece of text, joint takes care of 10 dogs, is very different from Sean has 5 toys. I mean, one is talking about dogs, the other is talking about toys for Christmas, but the mathematical concept is the same. So the AI model is able to generalize from, and this is called in-context learning, that from a few examples that you're showing the AI models as part of your prompt, and when you show it step by step how to solve the problem, it is able to now start solving similar problem. So this is called in-context learning, and this phenomena of showing the model step by step how to solve the problem, these researchers call chain of thought prompting. And in fact, they only discovered after they had built the model. They had not designed the model to have this capability, but they discovered that the model had this capability. So anyways, as Google built this model, Palm, and they saw that it not only had all these amazing natural language processing capabilities, it even had some mathematical reasoning capabilities. Guess which all products Google launched using Palm? The answer is none. Because Google was very concerned about potential downsides. Because this model, had multiple downsides. It could hallucinate. So many times it would give amazingly correct answers, but a lot of times it would completely hallucinate and give a completely made up answer. Another problem, bias. It would show bias against minorities, against women. In fact, my own team was doing analysis of bias in a non-Western context. So our team was amongst the first to study bias in these large language models from a non-Western lens. And we saw that indeed these models were showing bias based on caste, based on religion, based on nationality. So as a company, Google felt that, we should first address these problems before we start using them in our products. And meanwhile, what happened was there was a company called OpenAI, which launched something called ChatGPT, which had all of the same problems, but it started gaining traction. They showed that there were millions, and soon tens of millions, and now hundreds of millions of people who found value in utilizing these models despite all of those flaws of hallucination, bias, and so on. So Google also then decided to act, and in fact, that is when they brought these teams from Google Research and DeepMind together, and it is that notion of two things coming together which inspired the name Gemini, and started building these Gemini models. And again, I'll show you some of the capabilities which were like first of a kind as they got introduced. Apologize if this comes across as marketing, but I mean, the ultimate goal still is to convey the art of what is these AI models making possible. So about more than 2 years ago, we launched this Gemini 1.5 version with this long context window capability of 1 million tokens, which means 1 million tokens is roughly, so that context window is the amount of data that the model is looking at before it makes a prediction. Now, this long context means it could be fed as part of the input prompt, something like a 1-hour video. 1-hour video, which the model has never seen before, could be given as part of the input, and the model could be asked questions. Or it could be equivalent of dozens of textbooks. So let me show what the model was able to do on videos that it hadn't seen before.
An experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through a screen recording of example prompts using a 44-minute Buster Keaton film, which comes out to over 600,000 tokens. In Google AI Studio, we uploaded the video and asked, find the moment when a piece of paper is removed from the person's pocket and tell me some key information on it with the timecode. This screen capture is sped up, and this timer shows exactly how long it took to process each prompt. And keep in mind that processing times will vary. The model gave us this response, explaining that the piece of paper is a pawn ticket from Goldman & Company pawnbrokers with the date and cost, and it gave us this timecode 1201. When we pulled up that timecode, we found it was correct. The model had found the exact moment the piece of paper is removed from the person's pocket, and it extracted text accurately. Next, we gave it this drawing of a scene we were thinking of and asked, what is the timecode when this happens? This is an example of a multimodal prompt, where we combine text and image in our input. The model returned this timecode, 1534. We pulled that up and found that it was the correct scene. Like all generative models, responses vary and won't always be perfect. But notice how we didn't have to explain what was happening in the drawing. Simple drawings like this are a good way to test if the model can find something based on just a few abstract details, like
So this capability was later introduced into this product called Notebook LM, and I've seen many journalists actually make use of this Notebook LM, right, where you can feed it all kinds of data, videos, text, and so on, and it'll now help answer questions you may have. And there are even things like you can create a podcast automatically to illustrate various points and so on. I won't take you through all of these in the interest of time. Then we launched this agentic capabilities with a more natural interface where it could
agents that can see and hear the world around you. Think, plan, remember, and take action. Gemini 2.0 is what enables Project Astra, our research prototype of a universal AI assistant. Using capabilities like multimodal memory and real-time information, it lets you understand your world, live.
What can you tell me about this sculpture?
The sculpture you're seeing is called My World and Your World by Eva Rothschild, located in Lewis Cubitt Park in London.
What kind of themes does her work explore?
She creates abstract sculptures that invite viewers to interact.
Anyways, and then recently we launched Gemini 3.0, and one of the main things I would say
Gemini
that has
3
come out
is
of
the
that
strongest model in the world
is
for
programming.
multimodality and reasoning. It's our most intelligent model that helps you bring any idea to life. Starting today, we're rolling out Gemini 3 in our products so you can experience it for yourself. In Google Search, Gemini 3 enables new kinds of generative user interfaces. It codes interactive simulations like this one, custom built for your search. In the Gemini app, you can use the vast range of Gemini 3 capabilities for all kinds of tasks. You could supercharge how you learn, create, plan, take action, analyze complex videos, and more. You could start building with Gemini 3 Pro, available in the API today. We're even introducing a new platform, Google Anti-Gravity. It's our vision of software development at the frontier of model intelligence. It lets you use Gemini 3's agentic coding capabilities to accelerate how you build.
Again, this anti-gravity, what my team members tell me is within the last 3-4 months, their whole nature of work, how they used to do programming has changed. And this is not just my colleagues, pretty much the entire industry is seeing this kind of unprecedented step change in the coding capabilities of these models, that now instead of kind of having to program in the usual computer language, you simply describe the problem that you want to solve in English, in natural language. And this phenomenon of vibe coding has now really taken off, where based on your description of the problem in English, these models are able to generate code that often just works. And teams like robotics have been now using models like Gemini to, again, solve some of these tasks, which I'll also skip in the interest of time. The other thing which was very surprising in hindsight was the success of these models on tasks that require creativity. If you go back 10 years ago, even most AI experts were predicting that AI would be used to automate all these mundane, repetitive tasks, whereas creativity will remain this uniquely human endeavor. And you all know, again, what made possible was this class of models that we call diffusion models, but you all would have seen that today you're able to generate these amazing images, very high quality images, simply through text prompts. You're even able to generate very realistic videos like this, which is an entirely AI generated video with some text prompt. Let's take a quick look.
This ocean, it's a force, a wild, untamed might. And she commands your awe with every breaking light.
So this actor does not exist. Reminds me of Robin Williams, but is like entirely digitally created. Dialogue delivery, the dialogues being delivered in a very realistic human style, movement of lips in sync, and background sounds in terms of ocean waves and so on. All of this is AI generated. So, of course, today you do have large segments of Hollywood, Bollywood, which have started to use these AI models to generate content. And as journalists, now you would start encountering all of these deepfakes. So in fact, one of the technologies that our colleagues have developed is something called Synth ID, which is able to create a digital watermark, which by policy, Google will embed all AI-generated content with that watermark, Synth ID, to let third parties be able to detect whether this is AI-generated or not. Likewise, some very interesting work being done on AI. I'll skip, again, also, in the interest of time, some of this work with that the team did with Shankar Mahadevan, where he was able to explore different options in background music using this AI model. So with that, let me quickly spend a few minutes talking about my team's work on the theme of inclusive AI, which is, I believe, extremely important, which is how we make AI work not just for kind of the Western world, but for billions of people in other parts of the world who have previously not been touched by AI. And it includes work on handling, for instance, the diversity of languages spoken in different parts of the world. In India, we started with this benchmarking effort where we showed and this was a paper presented at one of the top AI conferences 2 years ago, where we showed this vast gap between the capabilities of these AI models on English versus most Indian languages. And we set about closing that gap. And I remember challenging our team, which had built a model called Mural, which at that time provided the largest coverage of Indian languages, 16 Indian languages. And I told Partha Talukdar, who leads that effort, that let's at least handle all the 22 scheduled languages of India. And then he pointed me to the data from Language Survey of India, which said that there are 60 Indian languages which have over 1 million speakers each, and 125 languages which have over 1 lakh speakers each. So he said, let's build a model that understands all of those 5+ languages. Something easier said than done, because the next thing he told me was 72 out of these languages were zero corpus languages. There was zero known digital data in those languages. And data is really the fuel for AI. The other thing we know is the same language is spoken in so many ways, different ways, depending on which region. In India, there's this saying called "Kos kos pe badle pani, char kos par vani," which means every few kilometers, the taste of water changes in our country, and every roughly 10 kilometers, the nature of voice changes. So that saying inspired this project called Vani, which we launched together with Indian Institute of Science, and we started collecting speech data from different corners of India and making it freely available. So far, we have collected data from 165 districts, already covering 109 Indian languages. And for 57 of those 109 languages, this is the first recorded digital data available to AI researchers. And in fact, in this process, we uncovered, so I guess our team wasn't trying to be journalists, but we did end up uncovering 8 languages that were not even mentioned in the last language census of India. And both our teams as well as a bunch of startups like Shunya Labs, SandLogic have been using this data. And then we worked on methods to integrate those capabilities into generalist models like Gemini. And now we were able to solve problems like translation. And the Translate team was able to use this to add in one shot 110 new languages to the Translate product about 2 years ago. And our team has been very interested in solving real-world problems. And one of the problems that we care about a lot is learning, because we believe that it is really kind of the key problem that we face as a nation, how to make every child be able to learn. And the ultimate goal and dream is to be able to provide a personalized tutor to each and every child in the country. And one of the things that we realized we needed to do was to overcome the language barrier. Because I remember facing that language barrier because in that same school, Sardar Patel Vidyalaya, our early medium of instruction used to be Hindi. And I remember when we switched to English suddenly for science and math, initially I struggled. And in fact, I went and bought the same biology textbook in Hindi so that I could follow that material. So we've been extending kind of these models like Gemini to be able to understand those languages. And this is kind of a demo.
And let's take a look at how Gemini can help.
नमस्ते।
क्या आप क्वेश्चन 3 सॉल्व करने में मेरी हेल्प कर सकते हैं?
हाँ, मैं समझती हूँ कि आप चाहते हैं कि मैं इस इक्वेशन 3x² + 5x - 2 = 0 में x का हल निकालूं। क्या आपने इसे ट्राई किया है और क्या आप मुझे इसके स्टेप्स दिखा सकते हैं?
हाँ, मैंने क्वाड्रेटिक फार्मूला यूज किया है। क्या ये ठीक है?
हाँ, ये सही तरीका है, पर आपने डिस्क्रिमिनेंट में एक छोटी सी गलती की है। आपको कोएफिशिएंट c के आगे एक माइनस साइन छोड़ दिया है। सही कोएफिशिएंट्स हैं a = 3, b = 5 और c = -2. इसलिए
Anyways, the point is that now these models are powerful enough. They can look at your the problem, they can figure out the solution, they can look at your homework, how you have done the homework, and then point out errors that you've made. Of course, a lot more work needs to be done because you have to have these personalized tutors be driven by principles of pedagogy, where you shouldn't just give away the answer. You should nudge the learner towards finding the answer themselves. But to us, this is a very promising sign that the dream of a personalized tutor for each and every person now looks like a reality. The other thing which our team has been working on is to also make these models understand different cultures and also different kind of nuances of different languages and different dialects. And so instead of showing a pre-recorded demo, I'm again going to be foolhardy enough to attempt a live demo again, which failed me last time, but I'll see again. So we recently, the reason I got to this version, it will come out soon because we added support for different dialects like Haryanvi, Bhojpuri, and so on, that we shouldn't just think of Hindi as one language that, oh, we understand Hindi, but the idea is that for the speaker from Haryana, it should respond in their specific language. So let me, I do have Haryanvi roots, so let me try to try my Haryanvi now. My Tamil didn't go too well. So let me try this now. हाँ जी, तो मैं हरियाणा से हूँ, हरियाणवी में बात करें?
राम राम, बहुत बढ़िया भाई, के हालचाल? हरियाणवी में बात कर श्या, बताओ कोई खास बात शेयर करना चाहो हो या कोई प्रश्न है मन में?
हाँ, ये बताइए, ये जो गीता बबीता फोगट और ये विनेश फोगट बड़े बड़े रेसलिंग मैच जीतते, बताओगे क्या क्या जीतते?
हरियाणा में तो गजब के पहलवान है जी। गीता फोगाट ने तो 2010 के कॉमनवेल्थ गेम्स में गोल्ड जीत के इतिहास रच दिया था। पहली भारतीय महिला पहलवान बनी थी वो।
इनको बाप ने ट्रेनिंग दी थी ना, उसके बारे में कुछ बताएंगे? Let me try again. इनके बाप ने इनको ट्रेनिंग दी थी ना, उसके बारे में कुछ बताएंगे?
जी बिल्कुल। इनके पिता महावीर सिंह फोगाट का बहुत बड़ा हाथ है। उन्होंने अपनी बेटियों को अखाड़े में ट्रेनिंग देने से लेकर उन पर जो सामाजिक ताने आते थे सब झेले और उन्हें मजबूत बनाया। वे खुद भी एक पहलवान थे, तो उन्होंने शुरुआत में ही ठान लिया था कि अपनी बेटियों को दुनिया के सामने चैंपियन बनाना है।
अरे आपसे ना बात करके बड़ा मजा आया। पहले सब हिंदी में बात करते थे, लेकिन हरियाणवी में बात करने का मजा ही और है।
तन्नू भाई, मन ने भी बहुत आनंद आया आपसे बात करके। अपनी बोली की बात ही अलग है, इससे अलग ही अपनापन जुड़े।
So anyway, you get the point. We are now trying to make sure that we offer a delightful experience to each user, right? Where this Gemini app is able to converse with each person in their native language. And today, yeah, it already does support 13 Indian languages reasonably well, and we are constantly working to keep improving. And also understand the cultural context, because when you're responding to a user in Assam, you shouldn't just come up with the response in English, simply translate that into Assamese. You should come up with a response rooted in the cultural context. Understand the local festivals, food, ways of dressing, and so on. So I have more slides, but I think I've already used up a lot of time, so I'm going to conclude in the interest of time that while on one hand, these AI models are showing very, very kind of high levels of capability that are transforming every aspect of the world, there is still a lot of work to be done, which is what gets us researchers excited, because there are a lot of open issues that need to be solved. And some observations that I have overall is that with AI giving people such a boost, huge boost in capability pretty much across the board, so far we have seen the most kind of dramatic examples in software development and media generation, but this is really happening across the board at a very broad range of tasks, that AI skilling will become an imperative for every person. And in almost every job, AI plus human will beat a human without AI. So we must not kind of get worried about, oh, is AI going to take away my jobs? And because of that fear, hold back on building up our capabilities in AI. We have to adopt AI and use the power to take our capabilities to a far higher level. The other takeaway is that a single frontier model, it can power hundreds and thousands of applications across multiple industries, a single model. And therefore, I do believe AI frontier models, it's a strategic capability that also India must develop as a nation. And finally, AI will really contribute to economic growth by solving so many problems that in a faster and more economically viable manner. So if you look at problems like solving different diseases like cancer, finding cures, finding drugs, so far we have been limited by human capability, right? The speed at which our human brain works and so on. Now, what we can, with that protein folding example, you can see the dramatic acceleration that is possible. So what AI is now making possible is the problems that could have previously taken us years to solve could potentially be solved in maybe even days or hours sometimes. And what used to take armies of people, a problem that might have taken previously 200 programmers working for 2 years, it could potentially now be solved by 2 programmers working for a few days. So if the problem was previously economically intractable, right, that it was too much investment, right, to solve that problem than the return you were getting by solving that problem, now, because of this changed equation, that you're able to solve these problems so much faster, so much more efficiently, now we can afford to solve many more problems in the world using AI. So those are the takeaways that I wanted to leave you with, that these are really, really incredibly exciting times that we are living in.
A very big thank you for this wonderful, to Dr. Manish Gupta for this wonderful presentation, which gave us a peep into an entirely new world, an exciting new world. And I'm sure we'll have occasion in the course of next year to have more such, perhaps hopefully from him and from others. I just want to add that the Future of Life Institute, which is a think tank which looks at the safety aspect of AI, which is a concern for a lot of people, has what's called an existential safety gradation of different AI companies. And we refer to OpenAI and Altman and ChatGPT. And he was himself one of the early supporters, in fact, part of this exercise, Future of Life Institute. But in the latest report card, OpenAI got an F, which is a failure, as you know. And so did every other major company except Anthropic, which got a D, a distinction, and Google DeepMind, which got a D-. So the safety aspect, which he, I think, hinted at, and what the big AI companies do with that is equally of concern, I'm sure, for all of us as citizens and as journalists. Just wanted to underline that aspect.